There are many theories about the origins of Jupiter. Here's what we think happened. Nearly 5 billion years ago, a star in our galaxy exploded. The explosion caused a nearby cloud of gas and dust to collapse and flatten into a spinning disk. The formation of Jupiter is essential to understanding the origins of our entire solar system, the formation of Earth, and the most basic foundations of life as we know. Jupiter is 1,300 times the volume of Earth, more than twice the mass of all the other planets combined, the fifth planet from the Sun, and the largest planet in our solar system. Because of its enormous size and powerful gravity, it is believed that Jupiter has influenced the formation and evolution of the other bodies that orbit our Sun. Unlike Earth and the other smaller planets, the composition of Jupiter has remained unchanged since the solar system began. Like a time capsule, Jupiter can help us reconstruct nearly 5 billion years of history. Hundreds of scientists and engineers in 5 countries have been working for more than 10 years to design and build the Juno spacecraft. The Atlas V 551 rocket, weighing 650 tons, launches and reaches a top speed of 4,500 miles per hour. In its proper orbit, the Centaur booster gives the probe its spin and sets Juno free on its journey to Jupiter. The spinning Juno spacecraft deploys its 3 massive solar arrays, which will power the mission for the next 6
trajectory, which is on a path relative to the Sun originally, now is flying by the Earth and is also influenced by the Earth's gravity field. It gets deflected out towards the planet Jupiter. The idea is that
Right now we're looking at how we can understand what the environment is actually doing to
power source. We haven't taken solar panels that far before and run an entire spacecraft that far from the sun.
After 5 years of being alone in space, Juno approaches Jupiter and begins reaching a top speed of 160,000 miles per hour, officially becoming the fastest man-made object in history. The main engine ignites to slow down the spacecraft, and Juno is captured by the powerful gravitational pull of Jupiter. Settling into the most challenging orbit ever attempted, Juno will come as close as 3,100 miles to the planet's cloud tops. Juno will continually duck below deadly radiation belts as it studies Jupiter in unprecedented detail for more than a year. Use remote sensing to inspect Jupiter from its innermost core to the outer reaches of the magnetic bubble the giant planet. Juno will be the first probe to visit the regions above the poles of Jupiter, witnessing energies in the magnetosphere that create its extraordinary ultraviolet aurora. Disprove theories about the types and amounts of materials that contribute to the composition of Jupiter. By peering beneath its clouds and discovering what Jupiter is truly like, Juno will also test our ideas about the formation of planets, as well as other major secrets of our solar system. Measuring the amount of water in Jupiter will help us understand how and where in our solar system the giant planet formed. For over a year. The Juno craft will dive deep into the atmosphere and many answers we find, there will always be more questions. Our search for understanding and meaning continues.